Good evening, everybody. It's night 2 of rotations, and it's Mrs. Pearson again. I know you're probably sick of my voice, but we're still going to rock out rotations going counterclockwise this evening. So hopefully you'll be ready to go tomorrow when you come and do some practice activities. Tonight's objective is that you'll be able to draw the rotation of a given figure on a coordinate plane and determine the properties preserved. Remember, preserved means the properties that we will be keeping. Oh, here it is, keep. That's what that means about those figures once they have been rotated counterclockwise. Now tonight is going to be the same thing as we did the other night, which was clockwise rotations, but we're going to be moving in the opposite direction. So let's take a look at how that's going to work out. In a rotation, an object is turned. We learned that when we did clockwise rotations. Tonight, though, we're going to focus on rotating a figure 90 degrees, counterclockwise, so much fun, about the origin. Let's go ahead and annotate that text. What does 90 degrees counterclockwise mean? Well, it means the opposite direction of a clock or to the left. So we will be now moving figures to the left in a counterclockwise rotation. It's still going to be about the origin. And if you remember what we talked about last night with clockwise rotations, all that means is that here at this point 0, 0, if I take a look at point A, which is 2, 1, and then point A prime, which is -1, 2, I am going to be moving that figure counterclockwise or to the left so that my image will be to the left of my original. And I will be pivoting about this point 0, 0, which means if I were to go ahead and measure the distance from 0, 0 to A and 0, 0 to A prime, that length would be the same from 0, 0 or the origin until I get to point A, and from 0, 0 to get to point A prime. That distance will be the same. And notice once again when I'm rotating 90 degrees counterclockwise, it's creating this beautiful 90-degree angle, which is why we're calling it a 90-degree counterclockwise rotation. Let's apply some rules. Here we go. We've learned our rules for rotations of clockwise rotations, 90 degrees. Now we're going to learn the rule for 90 degrees counterclockwise about the origin. Let's take a look at point A. Point A is located at 2, 1. Point A prime is located at -1, 2. Oh boy, here we go. If we start with XY, first of all, notice what happens to those coordinates. They reverse their order when we go to the image after a rotation of 90 degrees counterclockwise. So XY first becomes Y, X. Remember, look at this 2 here for A. Look where it ends up over here for A prime. The XY does change its position and become YX. Now notice what happens to the Y though. Here, it's a +1 in my original point. In my image, oh boy, it became a -1. How am I ever going to remember to change the sign on the Y? Well, remember, in a counterclockwise rotation, we move to the, let me erase. Hold on, I know I'm losing my train of thought. Here we go. We move to the left. We're moving that figure to the left. So guess which one changes its sign? The one I'm pointing to, or the Y coordinate. So in a counterclockwise, when we move to the left, it now points to the Y coordinate. So that's the one we're going to change the sign on. Well, let's bring that rule down here below. So remember, XY, first thing we do is reverse the order. So it becomes YX. Then when we move counterclockwise, we move to the left. So it tells me that Y coordinate will change its sign. And don't forget, that negative does not mean it's going to be a negative number. It means change the sign. I know I can't write as fast as I talk. The sign of the Y. There it is. Now let's apply it to a figure. Bam. Oh, this figure should look familiar to you. We did this figure the other night doing a clockwise rotation. Now we're going to move it counterclockwise. Well, first of all, let's think about visually, where should that figure end up? In which quadrant? If I'm moving to the left, counterclockwise says I move to the left, and it starts here in quadrant 3. Let me label it. And I'm moving to the left. Guess where it should end up? Oh, way over here in quadrant 4. Okay, now we're going to apply some rules to our points to see if that's actually true. First, let's take a look at point M. Point M is at -7, -9. I'm going to go ahead and write that in over here. -7, -9. And I first have to remember my first step of my rule is to switch the order of the coordinates. So -7, -9, and my original point now becomes -9, -7 in my image. Remember, I am moving counterclockwise or to the left. If I am moving to the left, this will actually change its sign. The 9 will become a positive. Let's go ahead and see if that works. Whew, okay, +9, -7. Bam, here's my point, M prime. And this time I'm going to label it as I go. +9. Woo, we changed the sign on that. Good thing I noticed that, -7. There's M prime. Now remember, because my direction of a clock goes this way, I'm going to be moving to the left. So far it's working. It's in quadrant 4. Let's look at N. Point N is located at -9, -3. Let's write that in over here. -9, -3. And I'm sorry, my handwriting is very messy with this pen. I just can't seem to control it. It's craziness. Now we're going to go ahead first of all and switch the order of our X and Y. So instead of -9, -3 in my original, in my image, we're going to start with -3, -9. In a counterclockwise rotation about the origin, I move to the left. It points to the Y coordinate, which I switched, so the 3 becomes positive. Let's go ahead and graph that. So N prime will be at 3, -9. Oh, wait, am I at there? Oh, yeah, there I am. There it is. And this is N prime 3, -9. I'm so excited right now because it's still in quadrant 4, and that's what I wanted. I rock this. Let's look at O. O is located at -2, -3. Let's go ahead and write that in over here. -2, -3. Now my first step is to reverse the order of XY to make it YX. So I write -3, -2. And now because I'm going, bam, counterclockwise or to the left, I change the sign on the 3. So it becomes +3, -2, and there it is. And that is O prime 3, -2. Last but not least, we have P down here. P down here is located at -4, -9. Now we're going to go ahead and write that in over here. -4, -9. My first step of my rule says I have to reverse the order of X and Y to YX. So I now have -9, -4. Because I'm moving to the left, because it's counterclockwise, I change the sign on the 9. So it becomes a +9, -4. Let's go ahead and graph it. +9, +9, -4. Sorry about that. I'm like a little confused. And that is P prime, 9, -4. Let's go ahead and connect those points. Now remember, I don't have a ruler. You people do, I'm hoping. So connect your points as straight as you can using that beautiful ruler. Why not connect it? Bam. Here they go. Oh, gee, there it is. There's my image. So remember, this is my original because it does not have any primes on it. This is my image after a 90 degrees clockwise or counterclockwise rotation. There it is. And it ended up in quadrant 4, which is where we expected it to end up when we first visualized the figure moving in a counterclockwise direction. All right, let's look at those properties preserved. Remember, the word preserved means what is kept, or what do we keep the same about those figures? Let's look at these two figures up here in this coordinate plane. Notice that the distance is preserved, which means the lengths of the segments are the same. In other words, line segments map to line segments. All right, let's take a look at a line segment. Look at PQ up here. 2 units. 2 units is the length of PQ. Look at P prime to Q prime. Bam, 2 units. Holy moly, it's true. The line segments do map to the line segments because those are corresponding parts. I love it. They're rigid motions. I love it. Let's look at angle measures. Here they are, angle measures. Do they remain the same? In other words, angles map to angles, which means they will remain the same. Look at here. Look at this little PSR angle right in here. It remains the same as P prime, S prime, R prime. Bam. Those angles are the same measurement. And if you had a protractor, you could actually measure it. Because our line segments map to line segments, that must mean our perimeter, our distance around the object, has to remain the same. Because our line segments map to line segments and our angles map to angles, our area also has to stay the same. Bam. Last but not least, orientation or the lettering order also remains the same. Let's prove it. If I look up here, P goes to Q, Q goes to R, R goes to S, and S goes back to P. Now let's look at our image. On our image, P prime goes to Q prime, Q prime goes to R prime, R prime goes to S prime, and S prime goes back to P prime. Do these all match up? Oh, yes, they do. I'm so excited right now. So orientation stays the same. Tomorrow, we're going to be doing some activities with some counterclockwise rotations. So be ready for it. And I'll see you then. Have a great night. Bye-bye.